Hey everyone, today we're gonna be doing a lead code question which is merge nodes in between zeros. So before we start this question, please do like and subscribe this channel so it motivates me to make more such videos. So in this question, it is given you are given head of a linked list which contains some integer separated by zeros. They're saying the beginning and the end of a linked list will have zeros as a value, and for every two consecutive zeros, I need to merge all the value of a particular node lying in between those two single nodes. Okay, so they are asking like, okay, sum up all the value between two nodes, two zeros, and make them in a one node common. Okay, so let's see what else. Like they're saying, return the head at last. Fine. So here are some example. We'll look it one by one. Let's see the constant first. They're saying, okay, the number of node can range from 3 to 2 to the power 3 to 2 into 10 to the power 5. Okay, so that means like minimum you will be having three nodes because there will be exactly two zeros like in the first and the last. You can say in the start and the end of a linked list you will be having a zeros for sure, and there will be at least one number which you need to return as a uh, you can say a merge node. Okay, the number inside that node or value inside that node can go from 0 to 1000, and they're saying there's no two consecutive node with value zeros. So they are saying there will no two nodes having the value zeros, one after another. And they're saying like there will be some nodes like beginning and the end will have the value as a zero. So let's see like how we can do this question with some example. So let me take the first example itself. So we are given some array. You can say not a array. We are given some head of a linked list. So let me write this in sort of a array first. Then I'll make the linked list. Okay. So I have this node as a value of our linked list, and let me create that linked list now. So let me take one example for each. Okay. I have multiple nodes. I will just create some copies. Let me take one more. Okay, fine. So I guess this should work. Let me write the value first. So I have value as, so initial value is 0, then 3, then 1, then 0, then 4, 5, 2, and 0. Okay, so it's not required now. Okay, fine. So I have this node. Okay, so let me make it large. Okay, I have this node. Okay, so what they are saying like, okay, you need to merge this linked list in such a order. Every node between two single zeros, you can say every node, you can say any node. Okay, okay. So we need all the node between two zeros to be summed up into single one. So if I say this 3 and 1 is coming between this two zero, that means I need to sum up this value, make it 4, and I just need to have this one as a result for this particular result set. Again, now between these two zeros, I have this 4, 5, and 2. So I need to sum up them. It will make 11. Okay, 5 plus 4 is 9, and 2 11. So I need two values. Like if I say the output should be for, I'll say output should be here 4 comma 11, because I have clubbed these two value between these two zeros, and again I have clubbed these values between these two zeros. So I need to return the new nodes, or you can say I just need a node with having the sum of value of any node between two different zeros. Okay. So if I say like how we can do this, like what are the approaches we can find out. So there's like very brute force approach. If you see here, like we have this array, or you can say this is our linked list. We can create this array. Okay, we can iterate over this linked list and we can store these value inside a array. Now what we need to find, like, okay, we need to have values between two zeros. That means I might have some window like this, like I have these two values as a 0 0. Okay, these two as a 0. Now I need the value inside that particular frame. If I say I have this window with two zeros, that means I need all the values summed up and I need to return this as a single unit. Okay, so if I say this particular unit will return me 4 from here. Now if I say I have another window, this window, okay, so this lies again between two zeros. So if I say this window is again between two zeros, this including this one. Now if I say the value returned from here will be 11, that means I need to return the you can say 4 and 11 from here. So how I can approach this question, like, okay, so what I'll say, okay, I'll start from this particular node in the array, like I'll store this particular linked list in array form, and I'll start from here. Okay, if I say I started over the index 0, let's say like I have some indexes 0, 1, 2, 3, 4, 5, 6, and 7. I might have two pointers, let's say like left and right. uh, this is my left and right. Okay, so what I need to do, okay, if I found any of the right pointer equals to 0, this right pointer equals to 0, that means I need to sum up all the value, and I need to place this right pointer to the next 0. So what I'll say, okay, uh, if I found both left and right equals to 0, that means I will be shifting my right pointer until I find the next 0. So let's not start from here. If I say, okay, because in the question they are saying you will be having at least two zeros. So what I can say, okay, I can start my left from here, right from here. I'll just keep on appending this result. So what I'll say, okay, I might have some value called sum, let's say it is sum. I will keep on appending the right value over here. Okay, so I again iterate over here, again iterate over here. For this particular result set, I'll get 4 from here. When I get another 0 in the right pointer, what I'll say, okay, I'll make this sum equals to 0. Before making this sum equals to 0, I'll append this value to the result set. So I'll say, okay, result dot append, or I'll say, okay, this is some result array, I'll append 4 here, or you can say sum over here, whatever sum is there. Now whenever I reaches this right pointer to 0, that means I need to reset my value. So I'll again start my left over here, right over here. Okay, again right and left over here. What I can say, okay, I'll again iterate one by one, I'll find the result set equals to, like, I'll sum up all the value, and whenever I reaches to another 0, I'll just place this particular result set in the array. You can say if I have this result array, for this particular window I have added 4, for this particular window I have added 11. So if I say, okay, this particular approach works, but having the time complexity is like order of n for iterating this linked list once, and this array, you can say the result set once. But we are using extra space because we are creating some array. How we can optimize this? So if you look here, what we are searching for, like if we are sitting over this place, like if what if like we do not create this particular array, we simply iterate over this linked list. So I have my pointer over here, one pointer over here, I'm just searching for the next 0. So whatever values are coming over this particular frame, if I say, if I have started one pointer from here, let's say I have one ptr over here, or just say like previous, both previous, and I'll say, okay, the current and previous is at 0 0. Now I'll say, okay, I'll move my current pointer over here. If it is a value, I'll simply say, okay, take this value and sum up. So I'll say, okay, this value to be added over here, plus plus. So like this uh, I'll say, okay, this value I have added over here. That means I have added 3. Again, my current will go here. So what I'll say, okay, add this also as this value also over here. Now my current reaches here. My current reaches over here. That means I found another 0. That means I need to place this pointer, like now I have this value, like I have updated this value twice. So first it was 0, then I have added 3. Now again I have added 1, that it become 4. So I have this particular node with value 4. I just need my next pointer over the next 0. Okay, so I have pointed again this value to 0. Now we need to do the same. So this time this will become previous. Again, this will also become, it is like currently it's current. Now again I'll point my current pointer to next. Again it will add 4 over here. It will go again to 5. it will go here 5, it will append this value 5 over here. Okay, again it will go to 4 2, so it will again add this value 2 over here. Again this current reaches to 0. That means I cannot I just need to append this value, and I need to have this previous pointed to the next one. So if I say okay, this particular next will be pointed to, let me say this particular will be pointed over this next. Okay, but if you see we are just modifying this particular cursor one after the another, what if I have a double zero, so I have single value, it will be reaching over here. Okay, if I have this one value, I'll say okay, I got this one, and then I reaches to 0. So that will be going to an infinite loop, because I'm just searching for the next 0, and then I'm just updating my previous pointer. What if I just not able to reach this previous to the 0? That means it will go and loop again and again. So we can do we can iterate, or you can say we can modify this approach itself. So let's take the same values. So I have this to be cleaned up, 1 second. So I have this, our, let's remove this also. Okay, so this and this, I have this as zeros. Now what I can say, I can do one more thing. So let's say take the first non-zero value. Okay, I reaches here, let's say this is now a PTR. You can say a pointer. This is some pointer. This is non-zero pointer. Okay, what I need to do, I need to append all the value to this pointer, which is also non-zero. So I can append this value again. You can say my current was here. Okay, current was here. I came to here. I came this, after moving one iteration, I got this as a current. Current means okay, I got this value which is non-zero. That means I can store this particular address somewhere. So I'll say okay, store this value in the PTR pointer. Okay, so I store this value as a PTR pointer. Again, I shift my current over here. I'll append the value over here. So I'll say okay, increment the same value with node value of a current. This current reaches to 0 again. Okay, this current reaches 0 again. That means I need to shift this pointer to over here. That means I will be placing this value to my next pointer of a current. Okay, so if I say instead of placing it to 0, what if I place it over the next value of a current? So if this current reaches to 0, that means I no longer require this particular value. I just need a non-zero non-zero pointer, or you can say non-zero node I'm looking for. So instead of pointing to 0, I'll place this current pointer. If I say this is my current pointer, a PTR, I need to place this particular value to my non-zero value. So the previous approach we are looking for 0. This time we are looking for, if this is a current value, I'm just placing this next value over here. So this time if we have only two nodes, let's say 0, 1 and 0, here it is null. That means this pointer is ended. So if I have this particular node, what I'll start over here, this is a current, so I'll check for the first non-zero value. So I'll say okay, previous and current both are 1, and I'll check for the first non-zero, then again the non-zero one. So if I say pointer of a current shifted with one position, it is coming to 0. If I found any 0, I need to place this next value to the current next, that means null. So if I say my head is at 1, I'll say, and the 1 is pointed to null over here. That means I'm able to successfully generate the output. So let me show you with some example of a code, it will be much easy to understand with code. So let's say I have some current pointer which is pointing to head. I'll iterate over this current pointer until the next value become nulls. Okay, so if you see here, it is mentioned you will be having the beginning and the end as a 0. That means it will be having at least 2 0 and 1 value. So I'm very much sure I need to stop before the last 0, and I need to return my head over here. Okay, so also one thing, if every node have, like every linked list have initial 0 and the end 0, beginning and the end 0. That means instead of using the first value, I can just skip the first value. So I'll say I'll return the head next, the next value of a head. Okay. Now I'll iterate over this array. So I need to store my previous and the current over here. So what I can say, like, okay, I'll have my current. Now this current needs to be pointed to the first non zero value. So I'll say, okay, if I started from 0, the next value will be like, okay, next value will be my non-zero value, because they are also saying there will be no two consecutive node with zeros. So if I have my first value as a 0, that means I can have the next value as a non-zero. Similarly, I can use this as a previous pointer, or you can say current pointer. Uh, you can say non-zero pointer or the PTR. So I'm storing the current pointer. What I can say, okay, I'm just checking for the current node, and it is having the next value as a non-zero. So for every pointer I'm checking, okay, what if like its next value is a non-zero value? So I'm just iterating until it's non-zero value. Once I found the value as a 0, I'll just terminate that loop, and I'll like here I'll say, okay, if it is fine, so I just need to like I'll say, okay, the previous value should be updated with the current value, whatever they have. If it is a non-zero value, okay, it should be added to the previous value each time. Like if I say this is a node 3, or let's say this is a node 4, so 5 will be included over here, 2 also will be included over here, because we are pointing our previous to 4 over here. Okay, this 4 is pointed with this previous. Now each time I will be going my next pointer, like current will be going to the current next, as usual, like the linked list approach. Similarly, if I'm doing this and it is checking for the current next value, that means I will be stopping before one pointer which reaches to 0. That means if I say now current is equals to current dot next, that means like now current is pointed to what? Now current is pointed to 0. If current is pointed to 0, that means I need this. If I say, okay, this previous value, what I am like, this might be our head. So I'll say, okay, previous next should be the current next. Okay. So I'll say, okay, the previous next should be the current next. Now current reaches to 0 over here using this case. That means I need the next non-zero value. Okay, fine. So if I say this previous pointer, like the 4 pointer, now will be placing over the null, because over here we got this as a 0. If I say this particular step make the current reaches to 0, and this step will like place our 4 next to the 0th next, that means it will go to null. So that's all for this approach. Let me compile this one. Let's say like let's see it's working fine or not. Okay, so we missed some case. So what I need to say, okay, I need the current next value. Okay, fine. We are checking for the every next value. Here we are looking for every next pointer next value. So let me compile this code again. So we are just adding every current pointer next value. Okay, so let me compile and submit this code. So I can see this approach work fine, and it is bit optimized. Like we have done this approach in order of n time complexity without taking any extra spaces. So yeah, that's all for today's question. Thanks for watching.